All right, so here in this problem, we're taking it a step further. We're trying to not only see if the mirror will work, we're trying to figure out where to place the mirror so that blue can see yellow and yellow can see blue. So in this particular instance, they're coming out and telling us that they're standing 90 meters apart. So the total distance between them is 90. And it says blue is standing 20 from the wall. So we know that they're 20 from the wall here, and that yellow is standing 40 from the wall. And so our goal is to figure out where this mirror is going to go, somewhere in between, so that they can see each other. So again, there's a drawing of it here. I'll just make a mark. So this ray has to bounce off from one and reach the other. I didn't draw that great. Yeah, you get the idea. These angles have to be the same, which means these triangles have to be proportional. So one of the easiest ways to approach this, I think, is to look at blue, and whatever their proportions are vertically, they're going to be the same horizontally. So in other words, 20 versus 40, if you can do in your head, 20 is about 1/3 of the distance here. So 20, the distance from blue to the wall, divided by the total distance from the wall. So blue is 20, yellow is 40. That's a total of 60. That ratio is going to be the same as the distance from blue to the mirror as total. So 20 divided by 60, if you take that, you get a fraction. In this case, it's 1/3, or you can use it as a decimal, 0.33. If you take that fraction and you multiply it by the total distance between them, then, so 1/3 times 90, you get 30. That will tell you how far from blue you need to place the mirror. So according to this, 1/3 times 90 is 30. I need to place the mirror 30 away from blue, which puts it here. Now, if that means 30 here, then there's 60 left over here. And here's probably the most important part of this is checking your work. So remember in the last video we showed, can they see each other? We said they could see each other if we prove these triangles are similar. So if we take the wall distance divided by the distance into the room. So for blue, the wall distance we just calculated is 30, divided by the distance into the room is 20. And what we just figured out for yellow is that the distance from him to the mirror, or her to the mirror, is 60, divided by the distance into the room is 40. Both of these are the same. They both equal 1.5. So because these are equal, this checks out, and we can say they can see each other. So basically, you take the distance, how much it contributes to the total, and then multiply it by the distance between. And again, check your work. You should have similar triangles when you're done. So in this case, 30 away, they should be able to see each other. You can do this whether blue is closer to the wall, farther from the wall, the same distance as the wall. But again, the most important part is probably just checking your answer, and you'll avoid making any mistakes. And they don't have to be nice, perfect fractions like this. You know, when you divide, you get a decimal like 0.1276, and you would just multiply that by the total distance, and that would also solve this problem. So that is about it.